Okay, hello everybody, what's going on? This is Mohammed. Welcome to another video. In this video, I'm going to teach you how to solve for the shaded area in this figure. So we have here a rectangle whose side lengths are 11 and 13. And we have 6 squares that are drawn inside the rectangle and that touch in the way that is shown here, the sides of the rectangle. So the question is to solve for the shaded area. Okay, so in order to solve for this, what I'm gonna do here, I will first draw a line segment from this point here to this point, and another line segment to the other side. Okay, and then I will move this a little bit to the right. I will highlight this in a blue color and the other segment in a red color. And then I will do the same thing here. I will also draw a line segment from this point here to this point, and from this point to the other side of the rectangle. And again, let me move this a little bit down. And then I will mark the first line segment in, let's say, a green color, and the other line segment in a red color. Let's leave it red. And then we need to notice one thing, that the angle here is alpha, is the same as this angle here, which is alpha. And the angle here is a right triangle, of course, and this angle here is 90 minus alpha, so, and this is also 90. So the angle here is going to be alpha as well, which is the same as this angle here, alpha. Okay? And let's assume that the side length of the square, of each one of the squares inside the rectangle is A. So this is A, this is A, this is also A, this is A, and also this is A. And again, this is also A. Now, let's find the line segments that I have marked in different colors. So I will start with the blue one. The blue line segment here is equal to basically 2A sine alpha. So it's twice A sine alpha. Now, how about the red line segment? The red line segment is nothing but 3A cosine alpha. 3A cosine alpha, which is basically this line segment, but projected vertically or horizontally with an angle of equal to alpha. Okay, and then I will do the same thing to the other side. The green line segment here is equal to the square side length A sine alpha, so it's A sine alpha. And the red line segment is basically the same as the other red line segment, which is 3A cosine theta, 3A cosine, alpha. And then I will form two equations, because I know that the rectangle side length is 13 and 11, so I can form two equations from that. The first equation is going to be twice A sine alpha plus 3A cosine alpha is equal to 13, and I will call this equation number 1. And I'll form another equation using the other side length of the rectangle, which is 3A, A sine theta, sine alpha, plus 3A cosine alpha is equal to 11, and I will call this equation number 2. Now, let me move these equations a little bit to the left. Okay, so now what I'm going to do, I'm going to subtract equation 2 from equation 1. So equation 1 minus equation 2, that's going to give us A sine alpha, and 3A cosine alpha is going to cancel out with 3A cosine alpha, and 13 minus 11 is going to give us 2, and I will call this equation number 3. And basically, I can form a right triangle whose angle is basically alpha, sine alpha is equal to 2 divided by a. So this side length is 2 and this is a. And the other side length, of course, is going to be the square root of a squared minus 4. And then what I'm going to do, I'm going to substitute equation number 3 in equation number 1. And that's going to give us 2a sine alpha is equal to 2. So if we multiply that by 2, that's going to give us 4 plus 3 cosine alpha equals 13. So that's going to give us that cosine alpha is going to be equal to 13 minus 4, which is 9 divided by 3. That is equal to 3. And that is equation number 4. And cosine alpha, we can get it from the right triangle that we have just drawn. It is equal to the square root of, a cosine alpha is, if we substitute 3 in 1, 3 is a sine alpha, which is equal to 2 instead of a sine alpha. So that's going to give us 4 plus 3a cosine alpha equals 13. So 3a cosine alpha is going to be equal to 13 minus 4, which is 9. If we divide both sides by 3, that's going to give us a cosine theta, which is equal to 9 by 3, which is 3, which is equation number 4. Now, using the right triangle that we have just drawn, a multiplied by cosine alpha, which is basically equal to the square root of a squared minus 4 divided by a. So a is going to get cancelled with a, and that's going to be equal to 3. That tells us, in a way, that a squared minus 4 is going to be equal to 9. And from that, we can calculate for a squared, which is 13. Okay, and now, simply, we can find the shaded area as the area of the rectangle, which is basically 11 multiplied by 13 minus the area of 6 rectangles, whose area of each one of them is a squared. So minus 6 multiplied by a squared, which is basically 13. And that's going to give us 65 square units. And that's the answer to this problem. Okay, so if you guys like this video, hit like. And don't forget to subscribe to the channel and click the bell so you don't miss anything in the future. Thank you for watching and see you in another video.